Awesome. All right, well, let's get going. First of all, thank you all so much for inviting me and having me here. It's really a pleasure. And it looks like you guys have had a great lineup today. So I'm just really happy to come and share this with you. So I wanted to do a little bit of a talk through about secure migrations and specifically WPA3, um, how to do it, what to look for. And so I've taken different pieces of content and brought them together in a little bit different way for you guys for something special here. So let's jump right into it. And I did have a couple of other little updates to share for you guys. So I did recently publish a book with Wiley called Wireless Security Architecture. Looks like this. It is available in print and Kindle and ebook. It's pretty long, but it has a lot of cheat sheets in it. And some of the content I'm going to cover today is from the book, but a lot of this content where I'm doing these presentations with you guys live like this is updated more regularly as WPA3 changes and as we get a little bit more information. But the book runs through everything that a network engineer needs to know for securing Wi-Fi, including designing, planning, and architecting, hardening, monitoring, everything about radius and 802.1x. And so two cool things there. I did get permission from Wiley to release chapter 3 in its entirety, which is everything about radius and 802.1x and EAP for a wireless engineer. So I'm going to be making that available for free in the next week or two. The other kind of neat thing is I know that a lot of times these books, especially coming from the US, are really expensive. So just this week, they released a humble bundle where you can get books in PDF or ebook or EPUB. And this particular bundle has 18 books in it, including mine. But a lot of great content and security. A lot of my friends that have written books have books in this list, and it's 18 US dollars total, which is about 88 real for all of the books. And you can spend less money and get, just 5 of the books or 11 of the books. But if you spend that 18 US dollars, you get all of the books in that bundle. So if you're interested in it and you like some of these other titles, that's just a really great deal. And I wanted to share that with you guys. And that QR code will take you to there. So if you go to Humble Bundle and you look under books and cybersecurity, you'll see it. And it looks like it's running until December 11th. So you have a couple weeks to do that. So let's talk about WPA3 and how we got here. For those of you guys and girls who've been working in Wi-Fi for a while, you probably remember that back in the day we had WPA2, and I'm going to say back in the day because even though that was our most recent advancement, it was still almost 20 years ago. So we've been using WPA2 for a long time, and in the book, I don't even really cover much about WEP and WPA, the first version, because it's just so old. I mean, I supported those on networks for a long time and put mitigating controls in place, but the reality is we're just past that now. So most of what we're looking at in networks is on WPA2. So then we get into the next steps in evolution and Wi-Fi security. And we're waiting because, again, WPA2 came out in 2004. So we're still waiting. I keep waiting. The waiting continues. 2010s come and go. And then this guy pops up. He's a researcher. And as if WPA2 wasn't broken enough, he just kind of kept breaking it all over in new ways and keeps doing that for us. He's had 20 years to break every piece of WPA2 along with some other researchers. So at this point, WPA2 is just dead. Like it's dead, buried, decayed, mummified, and there's just really nothing left of it. And I'm picking on my friends in the work groups because the Wi-Fi Alliance and IEEE security groups, we're just waiting for them to do something. And I think they're watching soccer maybe because they're not coming up with new tools. And I'm joking. These are they're doing a lot of work in this space. But we're sitting there and we're waiting, and I'm just going, it literally anything. Can somebody please fix any piece of this? Because we put little patches in place for some things. But as you guys probably know, a lot of WPA2 is broken in ways not only we can't fix, but we can't even tell if an attacker has breached the network or, especially for passphrases, if they have managed to recover a passphrase. We don't even know. So again, we're just kind of waiting until finally, a couple of years ago, we get WPA3. And so now the party starts, and now here we are. But even though this has been around for a few years, I mean, we're going into 2024 in a couple of months. So not quite 4 years out there, but certainly let's say a good 3 years. Um, and all of the endpoints at this point that are going to support it have probably been updated to support it. So that gives us a good starting point. So my first question to people, and a little bit of reflection internally for myself and then the clients that I work with, is why haven't we already moved from WPA2 to 3? And I think there's 4 main areas here, and specifically in this order. So the first thing is just a lack of awareness. And what I mean by that is a lack of awareness about all of the benefits that we get from WPA3 over WPA2. So this first piece is that a lot of organizations out there, a lot of professionals out there just don't understand exactly how much better WPA3 is over WPA2. Now, you guys probably do because you're sitting in a room, you're at a Wi-Fi conference, and you care. But for every one of us who's really involved in the community and really pursues this as a profession, there's hundreds, thousands of companies and businesses all over the world who just don't have someone like you helping them through this. So the first is just lack of awareness. The second is then that we don't necessarily know how. And what I mean by that is in the products, it looks really easy. There's usually a button to check that moves us from WPA2 on a network to WPA3, or maybe we can do transition mode, which is just a different button or a checkbox. And the transition mode lets us do both WPA2 and 3 on the same network. But the truth is that it's just not that easy. And so I'm going to explain why here in just a minute, that there are some other challenges to consider and some ways to work around those. But this don't know how is, okay, maybe we know we should do it, but we don't really know where to start. The next hurdle is, well, we do know how to start and we do know how it should be migrated, but it's just too hard. Because I don't know about all of you, but most of us, a lot of us, we're juggling almost anything on the network that has an IP address, right? Like we're managing the Wi-Fi, but we might also be escalation for support and help desk for end users, or all of the weird IoT things and the printers and the phones and anything that has an IP address, even if it's a connected vending machine or a toaster. So sometimes it's hard. We know that there are going to be challenges and we just don't have any more hours in the day to deal with it. So let's say we work past all 3 of those issues. The next thing then is it does take time. And as you're going to see in just a minute, even if we've planned it, some stuff is going to break and we can't necessarily predict what's going to break when. And so then this last piece is, let's say we're ready to power through it. We know it's going to be hard, but it's going to take us off of something else. We can't do this task and juggle all of the other tasks that have probably been assigned to us. So the next thing is maybe we're lacking the stakeholder support. So the people in our companies and our organizations, it could be your peers on your team, it could be your manager, it could be somebody higher up the stack that's not a technical person, that they're not willing to give you or your group the time and the flexibility and the leeway to handle a migration like this. So those are the 4 issues that I usually see when we're talking about why didn't we do this already and why haven't we started this process. So I want to rewind just a little bit then and make sure we're all on the same page about some of the top benefits of WPA3. So going back to that first bullet of not necessarily knowing why we want to do WPA3, and there's a long list. There's a long, long list, and I could show you 50 slides on all of that, but I just want to bubble it down to my top 2 or 3 here. And that's that we have, well, if you want to do any of the new stuff, right, we have to do WPA3. So Wi-Fi 6E and Wi-Fi 7 require WPA3, and we can't do anything before that that's older. And that's great with me because, again, WPA2 is just so broken. The other thing is that we get this infrastructure integrity with protected management frames. And when we talk about protected management frames, there's 2 main pieces to it. Some of the frames are encrypted, which adds a layer of confidentiality, so you can't just, see in plain text what's happening between an access point and then the endpoints that are connected to it. So there is an encryption in sometimes. But the bigger benefit we get here is what we refer to as an integrity, which is just making sure that whatever the message is that was sent between the AP and an endpoint that's connected to it, that we've validated the identity of that sending party, which means if we have the AP up over here, and I don't know why I'm drawing an AP like that, but let's just pretend that that's an AP, and then we have an endpoint over here. All of these management frames for years and years and years have been unprotected. So when an endpoint gets a message like, well, hey, I want you to deauthenticate from this network, or the endpoint tells the AP it's going to disassociate itself from the network. All of those communications were not protected and could be spoofed. So somebody, an attacker coming in over here, could send little, oh, that's supposed to be a bone. So just pretend that's a bone and a little skull. There we go. Okay, so our attacker can come over here and he or she could send spoofed management frames to one endpoint, all of the endpoints, several endpoints, or to the access point. And so that's been a huge problem because even though we've used protected management frames for good purposes, we'll talk about that in just a second, it's a huge vulnerability when we're talking about the management of the network and the integrity of those communications that have been unprotected. So protected management frames are really cool. And what they're really doing is adding this authenticity to say that really did come from the AP that I'm connected to, or it really did come from the endpoint that's communicating to the AP. So that's a huge thing. And we get that throughout all of everything that's WPA3. And I'll talk about that again in a second here. And then the last piece is this passphrase security. So we went from what used to be PSK on a WPA2 network to now SAE, and I'll show you a graphic with this in just a second, on the WPA3 personal networks. And personal networks, I think, are very important because for as many people that might dismiss it thinking, oh, that's something you use in your house. It's something you use in the consumer space, not something we use in businesses. But the truth is we do use it in businesses. In thousands of environments and organizations I've worked with, I can think of very few, less than 5, and really less than 3, that have no passphrase, no personal networks anywhere in their environment. It's a very low number, especially when you get into mid-market and enterprise sized. There's always something that can't do 802.1x, and we have to get on the network somehow. So these networks are very prevalent everywhere, but especially in business networks. And so I think they're very important, and I love the security that we get with WPA3 on top of it. So I'm going to talk about that when we get to in a couple slides about SAE as well. And I've got a little cheat sheet for you there on some of the benefits. So in the protected management frame arena, I mentioned some of the frames are encrypted, but all of them it adds integrity after the four-way handshake. So you have to have this establishment of a relationship between the endpoint and the access point, and that's the four-way handshake where they exchange the keys. And then after the four-way handshake, pretty much all of the frames are going to be protected in some way, even if it's just integrity, even if it's just I want to make sure that that frame really did come from you and you're giving me the instruction. And then we have some, of course, that are going to be encrypted, but this prevents the spoofing that I talked about a second ago from both directions. It can also protect from a subset of denial of service attacks because we're not going to be accepting spoofed deauth or disassociation frames. It can also protect us from some replay attacks. So if a malicious user were to come into the space, capture some packets, and then resend them in a WPA2 network, they would be successful, and we might be able to influence the client behavior that way. But with WPA3, we can't do that. And then some man in the middle or on-path attacks are also going to be thwarted with protected management frames. And then I mentioned a second ago that we do use protected management frames for some good purposes right now. And one of them is captured right here. So in WIPs, wireless IPS, a lot of the over-the-air mitigation uses, well, really all of the over-the-air mitigation uses spoofed management frames. And so this is definitely going to impact how we think about our tooling. So there's WIPs. There's also anything that's a third-party tool. And what I mean by third party is not within the Wi-Fi infrastructure. So if you're using whatever, Cisco, Meraki, Aruba, Juniper Mist, Extreme, it doesn't matter. That infrastructure and those APs are going to have the keys that are encryption keys and the integrity key checks. And so what then happens is when you have the endpoints and this stuff is happening, this communication is happening, some of those action frames that we use for debug and troubleshooting will be encrypted, especially unicast. And so it's not even some, I would say it's most or all, and that is fluctuating over time. So some asterisk here, if we have this conversation again in 6, 12, 18 months, some of this information might change with what's encrypted and what's not. But for right now, most or all of the action frames are encrypted. And so if you're sitting over here with a tool and you're watching this traffic and now it's encrypted, you can't see exactly what's going on. You can see that the action frame was sent and you can see what type it was, but you can't see the payload. And so this is going to change our tooling, but I think for the better. I think for the better. So let's go back to that whole PSK versus SAE thing. And this is something that gets me really excited. This is a very simplified graphic because they don't actually share exactly what they're doing here in these other functions. But when we were on a WPA2 network, and that's what's up here, WPA2, and we're talking about personal networks or passphrase networks here. On a WPA2 network, we had PSK, and PSK was free shared key right here. That's why we called it PSK. And so what that meant was all of the endpoints used a common passphrase, which ended up being a common cryptographic key. It's actually what we were encrypting the traffic with over the air. So this wasn't great, and it wasn't great for a few reasons because all of the endpoints had the same cryptographic key if they used the same passphrase. So I'm going to put issues here. Shared crypto key is one of the main one. The other is that it could result in a short crypto key. And for those of you that don't follow along with a lot of cryptography, the strength of any algorithm, it's only as strong as its key length material. And so in the world of WPA2, if we said 8 characters, that's our minimum, right? That's been our minimum. It has to be 8 characters long. That is not long for a cryptographic key. We want it to be in the hundreds when we get into this area. So that's been a problem. When we get into WPA3, this PSK function is now replaced with SAE, simultaneous authentication of equals. And again, I just need to talk to somebody and figure out where they come up with these acronyms. I don't know. But it's the mechanism that says, okay, we're going to derive a unique encryption key from the passphrase. So it goes through these other functions. And so out of the other end of it, what we have is a unique cryptographic key for every endpoint that's connected to the network, even if it's the same passphrase. So if you guys are sitting there, and I don't know because I'm not with you, but let's say that you have a MBC 2023 network, and that is your passphrase for that network to get on while you're there at the conference. In a WPA2 passphrase network, all of the cryptographic keys are going to be the same. But in an SAE network with WPA3, each of your endpoints is using a different cryptographic key. So what that means is, even if I get the passphrase, if I'm an attacker or just somebody else on the network, I can't decrypt your traffic. It also means that the cryptographic key length is separated from the passphrase key length. So even if we have a passphrase that's 8 characters here, let's just say it's 8 characters just to be the same as the minimum before. You're going to get a key length that's in that, depends on the algorithm, but you're in the hundreds long. So the cryptographic key length doesn't depend on the passphrase key length, which is awesome because what it means is now we have something that's cryptographically strong. Now there are just a few other benefits of this upgrade to SAE. So let me talk about that. And here's a little cheat sheet for you. This is the other huge thing, an offline dictionary attack. This to me is this is the biggest thing. Because before with the WPA2 network, if someone were sitting in your business, in your space, outside your home, and they were running a tool set to crack WPA2 passphrases, they could do that in a matter of minutes. They can force traffic, they can force packets, they can capture that, and then they can offline run a dictionary attack. And I say offline, and I'm air quoting because the truth is there's a lot of tools on the internet. So when I say offline, off of your network, so they could just be sitting there. And if you're in a business at your cafeteria table or right down the street around the corner from your house, if they can get the signal there, and they can run these tools, and in a few minutes, they can crack a WPA2 passphrase. So that's what this indicates. It's susceptible to an offline dictionary attack. And it's just minutes. It's just minutes. You don't know that they cracked it because they were just sitting over there scooping up packets over the air while you weren't watching. You don't even know what happened. But when we get to a WPA3 network, the attacker can't do that. They have to be actively on your network, which means you can monitor for it and you can alert on it and you can do different things to automate some remediation there and keep that endpoint and keep that malicious user off of your network. So I think this is huge because right now, if I have a customer or I have a network and they're using WPA2 passphrase networks, I'm going to assume that network has been compromised. I treat it like a public network. It's no more secure than that because somebody could have walked in just 5 to 10 minutes. They could be on the network. They could be on the network. They could be decrypting other traffic, and they could probably be joining and then have the opportunity for lateral movement in that network, and you wouldn't know it. So I think this is a huge deal. That's why I spent a few minutes on it. We've already talked about the key length, and I talked about the unique encryption keys per endpoint. What I didn't talk about yet was this forward secrecy. So this other feature here, which means if we get the passphrase on a WPA2 network, so this is how it's been working. We get the passphrase on a WPA2 network, we can decrypt not only this traffic, but everything we might have captured before. So we can take that key and we can decrypt a large volume of traffic. So not just multiple devices, but multiple devices over time, including packets that were captured before. We can't do that, or an attacker can't do that on a WPA3 SAE network because of this feature called forward secrecy. So the packets over time are encrypted with a different type of a key rotation. So if somebody gets the passphrase, they're not going to be able to have captured a volume of data or packets and then retroactively decrypted that. So these are the kind of 4 or 5 main things that we get on these personal networks that I think is just such a huge deal. But the kind of crappy part is these passphrase networks are the hardest to migrate. So now I'm going to get into a little bit of that, the migration, our steps. And I don't know how you guys handle questions. I'm happy to be interrupted anytime. But I'm going to keep going unless you guys stop me. Cool?
Cool, Jennifer. Some
Awesome.
question from the auditorium? No questions here.
All right. I'll keep going.
Thank you.
So the tricky bits here are especially for passphrase secured networks. And I'm going to caveat this because this is actually technically inaccurate. The challenge that we have are it's not that it's passphrase networks. Let me just scratch that out. It's actually that it's endpoints that don't support .802.1x and or are not updated or can't be. Now, so if we take that definition of these are the things that are hard, the reason I want to differentiate it is because if you have Windows devices and Apple devices and Chromebooks and normal endpoints and laptops and tablets and phones on a passphrase network, you're probably not going to have a lot of problems with those. But where you're going to have problems is all of the weird headless IoT smart things in your home and in a business network. Maybe printers, but probably more like the thermostats that are connected, whether in your house or your office, smart plugs, your various devices that you can talk to throughout the home or business. And so all of those things that are usually connected to a passphrase network because they don't support 1x, or you've preferred not to configure them for 802.1x. So it's really it's really the problem is the endpoints that don't support these other things, or the endpoints that are very IoT-ish and aren't getting updates because we have something new and they don't know about it. So let's I'm going to talk more about this in a minute, but let me talk you through what some of the friction points are going to be here. So when you're doing a migration from WPA2 to 3, what you'll notice is on an enterprise class network where we're doing 802.1x, easy, easy. I'm not going to promise you'll never have a problem, but you can do 2 things. You can usually just enable transition mode to support WPA2 and 3 together on the same network. Or you can probably, if they're on a 1x network, you have some level of management over the endpoint. So you can just make sure that the network drivers are updated and they'll probably connect to the WPA3 network because remember, this has been around for 3 or 4 years now. So this for 1x, easy. Don't even worry about it. We'll talk through the options with that. I'm going to go to the other end of the spectrum here in the purple and talk about open and enhanced open networks. So I haven't really mentioned this much up until this point. I'm not going to cover it much in this talk, but for forever, we've had open networks, which is just open system authentication, which is just an open network. Now, sometimes we do stuff after the open network, like we might have a captive portal, right? Starbucks, Hilton, hotel, whatever. But it's just an open network to associate to the AP. You don't need a passphrase and you don't need to do an 802.1x authentication. It's an open system authentication. So enhanced open then is where we take an open network and we use the same good stuff from WPA3 and we add an anonymous encryption. Using a Diffie-Hellman algorithm. And all that is we're encrypting over the air, but not using any type of authentication. So it checks the box that we get to encrypt over the air, but it doesn't really give us much more security besides that. So if we take an open network, we add these things to it, now we have enhanced open. And the reason I have it down here that says very hard for now is this is very vendor dependent. So vendor dependent in a few different ways. Vendor dependent in the wireless infrastructure. Each of the manufacturers has implemented this a little bit differently, and therefore the client behavior interacting with those networks is a little bit different and unpredictable. We'll get to the point where I think this will be standard and normal and okay. But for right now, it's just hard. So most of the time we have an open network when we're servicing guests or transient users that we don't have management over the endpoint. And so they may or may not support enhanced open well at this point in time. So my recommendation here is if you're talking about a guest network, don't use it yet. If you're playing around and you have an open network that's your stuff and you have control over the endpoints, have fun, play with it, and see what you can do or what you can break. But for right now, I'm gonna not put a lot of attention on this. So then the big juicy piece here is that personal or passphrase based network we've been talking about. And this is it's not fun, and I'll tell you why it's not fun, but it is needed because this middle section here is where we get so much of the benefit from WPA3. So let me talk through what I think are 4 or 5 of the main technical challenges. And specifically, I'm going to focus on the passphrase network. And then I'm going to come back around after this and fold back in some of the other stuff with the enterprise networks. 4
Jennifer,
main things here. Your normal stuff.
sorry.
Yes. Oh, yeah.
Sorry to interrupt you. A question here.
Yeah.
On the last slide that you presented,
Mhm.
you told us about the transition mode, right, in the .1x SSID. But in your opinion, it's best to create a new SSID only with WPA3 and migrate the machines, or to have this transition mode using a current deployment?
Yes. So I'm going to get to the details, the technical details about why. But if we're looking at it in this slide context, I would say for these networks, you can do WPA3 only or WPA3. I'm going to abbreviate TM for transition mode, which means we're doing both WPA2 and 3 on the same network. I'm cool with this. And either one of those are going to work well. Now, ultimately, I would like to see everybody get to the WPA3 only because that's where we're going to get the benefit of the integrity and protected management frames and some other benefits that I'm not diving into too much today related to things like certificate validation for 1X. So WPA3 is better here. But compared to the passphrase network, it's a little bit better. Whereas on the passphrase personal networks, we get a big jump to what better looks like. On these networks, for passphrase, in 80 or 90% of the time, maybe not 100, there are always exceptions, right? Always the asterisk, it depends. On a passphrase network, I recommend this, a WPA3 only with a WPA2 only, and as many of those as you need. And we'll talk about that here in a second. I don't recommend transition mode for these. Again, there's always exceptions. I'm not telling you never do it. I just, as a general rule, I would start with this. And I think in the next 3 slides, it'll explain why. And so let's come back to this conversation in about 3 slides and see if that makes sense or if we want to dig a little bit more into it.
Thank you, Jennifer.
Yeah, my pleasure. So the kind of normal technical challenges we're dealing with throughout this are on a passphrase network. Again, I'm kind of focusing my attention on that for right now. We sometimes have a lot of things and we don't always know what they are, whose they are, or physically where they are in space, right? If they're wirelessly connected to a passphrase network, we have a general idea of the physical location of it, but within what, 3-5 meters, which could be, several walls if you've got offices or rooms. So we don't always know what they are, whose they are, why they're there, or what they're doing. There can be a lot of them. And even if there's not a lot of them, I mean, you guys know you have home networks and labs you're playing with. As soon as you start, I mean, I'm a very basic person. I don't run a lot of stuff in my home network and lab unless I'm getting ready for a training class or, putting screenshots together or testing something. But even just like normal, weird little household IoT things, there's probably 50 devices on the network and they pop up and then they go, some of them are on for a little bit of time and some of them are on all the time. And this thing talks to this thing and sometimes it's Bluetooth and sometimes it's Wi-Fi. So the sheer volume, and if I have 30, 40, and 50 devices, not as part of a lab, but as just part of just a house, imagine a business network. So the sheer volume is an issue. And then the time and effort. So any migration takes some amount of time and effort. I'm going to talk about a few more technical things here in just a second. And then the device capability. We don't always know what the endpoints can do until we're manually testing them, which is individual and incremental. But even with all of these, there's really none of this would give me any pause. Like none of this would slow me down during a migration. It probably wouldn't slow you guys down either. But the one main problem we're dealing with, the one kind of big wild card, is that even with all of those other issues, on top of that, we have these misbehaving endpoints. So these kind of misfit devices. And what I mean by that is some of them are not operating to spec. They're not operating based on, the IEEE standards. They have not been tested by the Wi-Fi Alliance for conformance in these areas. And so here's specifically what that looks like. The first one is that maybe an endpoint just can't do WPA3. There's a few reasons for this, and then when we get through the bubbles here, I'm going to come back around with some solutions. So some endpoints just can't do WPA3. That does not bother me. Okay, cool. No problem. What's next? The next thing is we have some endpoints that don't like multiple AKMs. And I'll show you an example here in a second with a screenshot of an advertisement with multiple AKMs. If you guys hit a problem a long time ago when we talked about transitions from 802.11r, FT roaming, several years ago when that first came out, this was a related issue where when you look at an FT network, you get the regular advertisement and then you get the second AKM for FT, right? And so some of the endpoints didn't like that. Some endpoints still don't like that. Now, they shouldn't fail, but they do. And you don't know that they do until you present them with multiple AKMs and then see what they do. And so this is a bit of a problem. especially for the endpoints that aren't getting regular updates like those IoT things. But there's even one bigger problem than this. And this is a new issue that we've seen because I think we got drivers, a lot of endpoints worked their way through this after we had the FT issues. And we said, okay, we're going to fix this problem and we're going to support multiple AKMs. So now the new problem is even if it supports multiple AKMs, sometimes the endpoints just lose their marbles and stop when they see an AKM that they don't yet understand. And so in the world of the advertisements, we might have an AKM for, let's say we had WPA2, and again, I'm talking about a passphrase network here, and then we had a WPA2, so these are going to be PSKs, right, with FT. That's 2 AKMs, and the endpoint goes, okay, no problem, right? We've worked past this. I'm cool. So now we go, oh, it's a transition mode network, right? We can do WPA2 and 3. So now we have a AKM for WPA3 and maybe even also one for WPA3 FT. It doesn't really matter at this point. If that endpoint doesn't understand some of this stuff is new, right? It won't even try to associate to the transition mode network. So TM, transition mode, fails. It will not even attempt the association. You won't see an error. You will have no indication other than the endpoint stops trying. So I'm going to talk through some solutions, but while I've got this up, what we've figured, and I've talked to Adrian about this and Peter McKenzie and several others, is the only way to diagnose this, the only way to know that this is the problem or that this is the problem with multiple AKMs is if we run a tool or a profiler and we say, okay, my first test is to present the endpoint with 1 AKM. Sorry, let me back out of that one real quick. Too many ones with circles. Okay, 1 AKM. If the endpoint goes, okay, yep, I connected, no problem. Test 2 is, let me present it with 2 AKMs that are known. And so specifically, I would say these are WPA2 AKMs, right? The endpoint connects to that. We know that this isn't the problem up here, right? Multiple AKMs is not the problem. So then our third test is we can do a couple different things. We can do 3 or more AKMs, but really what it's going to be is at least 1 WPA2 AKM plus 1 WPA3 AKM. So now we're advertising to it 2 AKMs, but also 2 generations, a WPA2 and a 3, and see then if it connects. And if it connects there, now you've worked your way through. That doesn't mean it necessarily supports WPA3. So what an endpoint should do, if it's behaving properly, is when it sees this, I'm going to switch colors. Let's go to blue. When it sees this advertisement here, I'm going to come back up here. And it goes, okay, I see a WPA2. I see a WPA2 with FT roaming. I see a WPA3 network. And I see a WPA3 with FT roaming. If the endpoint doesn't understand the 3 and the fast transition mode for 3, it should just show up to it as an unknown language. Like me trying to read Portuguese, that is not going to happen, right? But if the first 2 are in English and Spanish, and I go, okay, well, I don't know what the rest of this stuff down here says. but I see WPA2, that's in English. I can do English. And I see WPA2 FT, that's in Spanish. I can read Spanish. And I don't really care if the rest of it's in Latin or German or Portuguese. I'm going to go connect to the thing I know I can connect to, which is one of the WPA2 networks. That's what an endpoint should do. But some of them don't do that. And so they see the AKMs advertise that they understand, but then they see some that they don't understand in a transition mode network, and they just stop. They just go, okay, well, I can read that this is a WPA2, and that's a WPA2 FT roaming, but I don't know what the other stuff is. I'm not even going to try to associate. So this is the problem, not the rest of all of the issues with the volume and whether it supports WPA3 and all that. This is the issue that some endpoints won't even connect to a transition mode network. Now, there's one other problem, as if this wasn't complicated enough. So let's say we work past all of that. The last issue that we might see, and I'm going to just clear all of this for a second. The last issue that we might see is that even if an endpoint does support transition mode, whether it's going to connect using WPA2 or 3, it still might require manual intervention. So if we're talking about an endpoint on a passphrase network, manual intervention might mean a few different things. It might mean simply that you walk over to the endpoint and you tell it to disconnect and reconnect. That's it. Disconnect, reconnect to this network. Or you might have to jump through, it might ask you to revalidate the passphrase again. So if we go back to the question 3 slides ago of why I don't recommend transition mode networks, I'll scoot back here to that. That's why I don't recommend transition mode networks or passphrase.
Thank you, Jennifer.
My pleasure.
Awesome.
Fantastic. So let's talk about some of the solutions and some of the things we can do. So here's kind of some of the solutions we can work on. I think I've explained the why. I still have a couple of screenshots with what the AKMs are going to look like for you. So if the endpoint won't do WPA3, we have options. We can probably just update the endpoint. Now, obviously, back to that whole thing of if the endpoint supports 802.1x, it's one of those therefores. If an endpoint supports 802.1x, it probably is being managed and you can update it. So probably updating the endpoint is going to work well for you. If you can't do that because it's one of those weird IoT things, your other option is to leave it on a WPA2 network. Or you can use or try transition mode. If it's not misbehaving, then you're good. But you won't know it's misbehaving until you do those tests. So the next solution here, if the endpoint doesn't like multiple AKMs, you can try to update the endpoint. If that doesn't work, connect it to a WPA2 only network or a WPA3 only network. Just don't give it to AKMs. That also means not enabling FT probably. That third pink one that I think is really the hot button item and challenging right now is if it just spazzes out and stops trying to work when it sees an AKM it doesn't understand, that means you can't use a transition mode network. So in this particular case, you probably just want to leave it on the WPA2 network. And here's then where we're getting to running those two networks in parallel. So then the solution here, if it requires manual intervention, and there's a fair number of these endpoints, and I think the smarter the endpoint, the more often intervention is required because the endpoint recognizes that something changed. Even if you have the same SSID and you have the same passphrase, it still knows something changed. And so it might ask you to interact with it. And so if you're going to go touch the endpoint, go ahead and just move it to a WPA3 network. Why bother and do it twice? So just as a quick visual, because I'm a visual person, here's what it looks like. You see the couple of AKMs being presented here. That's that PSK meaning WPA2. And here's the SAE for WPA3 on a transition mode network. A properly behaving endpoint will connect to this, even if it doesn't do WPA3, but a misbehaving endpoint won't like it. So wrapping up with the how then, I've already covered this, but this is a slide with everything together. Wait for Open Enhanced until we have a little bit better adoption with the endpoints, a little bit better consistency. With 802.1x and EAP, you can do that today. I'm totally cool. I think you'll have good luck with transition mode, and I would run that as long as you need to, then get everything on WPA3. And then the personal networks with passphrases is where you're going to have challenges, with that last caveat and reminder that it's the endpoints that are the problem, not the passphrase network. So it tends to be the IoT type headless devices. And in that particular case, I would use two SSIDs, just like you guys said there. So that is the end. I'm going to thank you guys. If there's any last minute questions, I'm happy to take them. And appreciate it. You guys can follow me on LinkedIn as well for more content.
Thank you, Jennifer. There's a question on the chat. If you can take a look at it and see if you can, if you understand. It's in English, so you'll be able to read it and understand it.
That is helpful. Okay, so the question is, I'm used to seeing a lot of routers that have WPA3 transition mode. What I don't see yet is easy mesh with WPA3. When configuring that, I need to use WPA2 only. I wonder why. So you'll have to help me, Diego. Is easy mesh, fill me in, is that a specific vendor or is it just any meshing between APs?
Diego, go ahead and try to answer her question, or if you can on the chat. That's an exclamation point.
Exclamation mark. Not vendor specific. Okay. Yeah. So if we're talking about, and I'm just sorry, I'm easy mesh. I'd have to look that up. But so if you're just talking about meshing as in the relationship between two APs, that I don't know. So I have seen different vendors do different things. And in a different deck, I have a cheat sheet of, and in the book, there's a cheat sheet, and I think on my blog, of what the different vendors call different things, because they don't all call it WPA3 transition mode. It's all weird stuff. So yeah, I'm sorry, I don't have a good answer to that. I can definitely find out and circle back around with you offline. But I do think, we're at the point where the vendors are starting to push these features out beyond just the bare minimum of an endpoint connecting. Another example is for Intune. If you guys use Microsoft Intune, unless they've changed it very, very recently, you can't push to Microsoft endpoints a WPA3 network, even though it's been around for years. Even though all of the endpoints support it for Microsoft, in Intune, you can't push it. So there's still some straggling adoption related to that, but I'm hoping it'll change.
Yeah, great. Okay, so I have a question related to the AKM tests. That's very interesting. And I wonder if isn't it part of the Wi-Fi Alliance certification test for the devices? I mean, being able to support, multiple AKMs and stuff like that, right? Because we're pretty much doing a retest of something that's supposed to, work with WPA3, right?
That's another great question. So we had this conversation at WLPC Prague, just a month ago, almost exactly a month ago, where so if you guys find it's like a 20-minute session. I had a panel. I brought up Peter McKenzie, Adrian Granados, and Wes from Juniper from a product management standpoint, and we kind of talked through, because these are the people that I'm going to and asking that end of the questions, and then Stephen Orr from the Wi-Fi Alliance for the other end of it. And I've gotten some conflicting information. So what I've heard is that there is conformance testing, but I don't know that they test for that specifically. I don't know that they test for will the endpoint behave or misbehave if it has multiple AKMs, or if it shows an AKM it doesn't understand. So there is testing for the different features, but it's this weird in between world of, if we're not doing strictly this feature, but it's this default behavior that's not related to a feature, right? It's not WPA3. It's not a WPA3 issue, but a WPA2 only endpoint should still connect to a transition mode. I don't know that they test for that. And so Peter did suggest, like, he called it, forward compatibility testing. So that's certainly something that I think would make sense. And I would say that I think probably it's safe to say if an endpoint is Wi-Fi Alliance certified, it will behave just because they're working on other pieces for that certification.
All right. Thanks, Jennifer. Any other questions from the audience or on the chat online?
I just want to say hello, JJ.
Hi, Loriana.
Thank
How are you?
Good, and you?
I'm great. I'm great.
Okay.
It's so good to see you. Again, I saw Loriana in Prague too.
Yeah, it was nice. Thank you. Thank you to have you here. It's amazing for us, and thank you for your time. It's always very, very good to listen to you. So thank you.
Oh, thank you. It's really my pleasure to be here. Thanks, Diego, and thank you all for the questions. And I hope I will see you again.
Good.
All right. Thank you, Jennifer. Appreciate your time. Have a good day.